Hello everyone, I'm Devashish Khare. Let's solve today's problem of the day. Well, the problem is surround the ones. Uh, it says given a matrix of order n cross m composed of only zeros and ones, find the number of ones in the matrix that are surrounded by even number of zeros. Okay, and the surrounding of a cell in a matrix is defined as the elements above, below, left, right, as well as the four diagonal elements around the cell of the matrix. Okay. Hence, the surrounding of any matrix element is composed of 8 elements. Find the number of such ones. Okay, let's see how the question is actually going to be done and what it is actually saying with the help of this example. Okay, so here is the example. I've just formed the matrix of the same composition that was given inside your sample case here. Now, what is our task? We have to count the number of ones which are actually surrounded by even number of zeros. Fine. So if we are at this number, okay, firstly we have to check that if it is 1 or not, because we have to find out and look to the surroundings of ones, not zeros. So the very first thing is where we are standing, we have to check that that number is 1, right? Now we have to look towards its neighbors. What are its neighbors? We have to follow the 8 directions. That means we have our above, we have our down, we have the right, we have the left, but we also have these diagonal directions. Fine. So standing here, the possible directions are this down, this left, and this diagonal, right? So we have to see, we have to check each and every neighbor of this one. This is 1. That means what we have to find? We have to find number of zeros. Okay, the count of zeros is still 0. This number, it is not 0. This number is 0. Count of 0 is 1 now. Fine. Count of 0 is 1. Do we have any other neighbor? We don't have any other neighbor. That means the count of 0 is 1, which is not an even digit, right? That means we are not going to include this one in our actual counting of ones. Okay. Coming back to the next, this, it is 0. We don't have to count for it. It is also 0. We don't have to count for it. When we reach this one, right? When we reach this one, okay, when we reach this one, what are its possible neighbors? It is your up, it is your down, it is your right, right? And it is also these two diagonal elements. So we have to perform a check. This is 1, we don't have to count it. 1 0 found, 1 not counted, not counted, second 0 found, right? So we have found 2 zeros for this particular one. That means 2 is even and this one follows the condition, right? So the count of 1 is now going to be set as 1, right? Again, once the work of this is done, moving ahead, we have to look for this one. For this one, we have all the possibilities, all the 8 possibilities here, right? We have to look if the number of zeros are even, not counted 0, 1 0, 2 0, 3 0, 4 0, and 5 0. So this time we have 5 zeros. So we don't have to include this one as well because 5 is odd, right? Again, we go for this 0. We actually don't have to count for it because this is 0. We are finding surround the ones. Okay, so we'll end up here at this one. And for this one, let me check all the conditions again. Okay, what are the neighbors of this one? This, and this. We have to check. 0, it is 1, 2, and 3. We have 3 zeros, correct? It is odd. That means we do not have to consider this one as well. Out of this whole matrix, there is only one present that we are counting, right? So the final answer for this matrix is also going to be 1. All right. I hope you have now understood the question. And by the way, how it is being done, it is also clear in a very programmatic manner. Still, let's see our 4 directional traversal, how you are going to do that. Well, actually, instead of 4, this time we are going to be doing 8, right? Because we are also including our diagonal elements this time. So if again, assume if you are standing here at the center and your coordinates are 0 comma 0, you can assume it to be anything. You can assume it to be I and j. So what we can do to these I and j, that we'll be able to see through its neighbors. Okay. Now what we are doing here is, if we are, I hope you are clear with this is I, this is j, these are your rows, and these are your columns, right? So once you are here and you are going on, assume this cell, you're going to this cell. What you are actually doing is you're actually remaining on the same row, but you are reducing your column, correct? So for row, it is going to be 0, that means no change. And for your column, it is going to be -1, correct? What about this one? Well, we can make one thing clear is this. If you're talking about these three neighbors, what is happening is one column is getting reduced, right? If we're talking about these three neighbors, what is happening? One column is getting increased, thus +1. Okay. Now, let's talk about rows. If we are here, what we are doing? We are actually also reducing the row, correct? So this is going to be -1, correct? And again, for all this complete row, if we are seeing with this perspective, we are actually reducing the row by 1. So we are going to write -1. We are going to write -1. Fine. Talking about this row, we are increasing one row here. For this particular cell, we are reducing one column and increasing one row. So it is going to be +1 comma -1. This one also is going to be +1 comma, but this time +1, because for this particular cell, what we are doing, we are increasing the row as well as we are increasing the column. Now let's talk about this column. In this column, when we are seeing it from the perspective of this point, we are not changing it. This is going to be 0, and this row is getting reduced, this row is getting increased. Fine. I hope now it is clear that how we can actually travel to these elements. If we are having ij, and let's say we have to travel to this cell, so what we are going to do is we are going to minus I with it and plus I with column. Okay, this is what we are actually doing. So let's talk how we are going to code it. What I prefer is we make a data structure of all these combinations. Okay, and let's name it directions. And we are going to make a data structure, you can say a simple vector or a list of all these 8 combinations. And then we are going to use it to travel in each and every cell. Let's actually see the code for it. Okay, so once we have this matrix, what we are doing is we are performing a nested traversal. That means we are going to uh, begin from this particular cell, and then we are going to go on like this. Okay, so what we are doing here is we are checking that if that cell is having 1, because we have to check for 1, right? So once we are having this one, I have called this function check, which will be doing our further checking for all the neighbors. Okay, so once I have called this, what it is actually doing is it is performing count of zeros. Okay, so it will be counting what is actually the number of zeros that all the neighbors have. And how it will be doing it? It will be making use of this data structure, which I've just told you how it will be done. It is having all the possible combinations of the 8 neighbors that a cell can have. Also, you have to keep one thing in mind. Let's see if you're talking about this first element. Okay, if you're talking about this first element, what we are actually saying is we have to find out its neighbors. It only has 3 neighbors, although the checking will also be happening for all the 8 elements which does not exist. So for checking those that we are not going out of the bound of this matrix, we do have to check that as well. So for that, I've used this particular function. I've named it as isValid. It is taking my matrix and my indexes, and it is checking that I is within the range of 0 to n, and my j is within the range of 0 to m. Okay, fine. So one, I'm standing here at this particular position. What I'm doing here is I'm creating 2 new variables which are going to be the indexes of my neighbor. So assuming a -1 comma -1 is my first neighbor, what I'll be doing is standing at 0 comma 0, this is my the values of I and j. What I'll be doing is I'll be adding -1 and -1 here. This the I'll be checking this particular block, correct? I'll be checking this particular block. So even before accessing it, because once you access a block which is out of the matrix, it will throw an error. So before even mentioning it, what I'll do is I'll check that if this value is even valid, and it will be checked by this function. We'll be having true or false. If we know that this particular block is a valid block, then we'll check that if it is 0. Yes, if it is 0, let's check for this one. So if assume it is 0, what it is doing is it is increasing the counter. Fine. It is going to do the same thing for all the 8 blocks. It will check that if that exists, and if that exists, if it is 0 or not. If it is 0, it will just increase the counter. Eventually, inside this variable c, I'll be having count of my zeros. Then I'm checking if count of 2 is, if count of 0 is actually even. This is the basic condition for your for checking that a number is even or not. And I'm doing and with c. That means we actually are avoiding the case when we have 0 as the number of zeros. When we are having no zeros, that will also be considered as even. So just to avoid that, I'm doing and with c. Okay, once this will be done, it'll again go here, and this condition will pass on. Once this condition will pass on, then for that particular one, again coming to the one, we were checking for this one, right? So if this one is a valid one, we are going to be counting this. Okay, and eventually we have to return this counter. That's that how many ones we have in this particular matrix which follow the given condition. Okay, talking about the complexity of it, it is actually going to be O n cross m, because what we are doing is we are traversing through the matrix, right? We are traversing through the matrix. We are going to each and every column. And more precisely, we are going to each and every column, and from every cell, we are going in 8 possible direction. So this is going to be the worst time complexity of your this particular code. Let's try running this code. Okay, so here we have the same code. Let's run it. Okay, so it is working fine. Let's try submitting that. Okay, so it has passed all the test cases. I hope you have understood the problem. Please go through the video again if you found it anywhere a little confusing. And happy coding. Thank you.